the question of how will Femtocell technologies accelerate the cost-effective provision of ubiquitous broadband?
Thanks, Albert. So let's move to the presentation on femtocells. So you already know what femtocells are. As Misha argued, I mean, 1,600 factor of these improvement in the recent years, in 40, 50 years, come from smaller cells. So what we are presenting here is what can we do with femtocells? How can we have an harmonic architecture that makes all these femtocells work in a coordinated manner, not just in an isolated manner. So the important word here is network. Let's say BeFEMTO. This is done in the framework of a European project called BeFEMTO, and what I'm presenting is some of the contributions that the CTTC did in this project. It's a research project, but it's an IP, it's an integrated project, which means that it's industry-driven, meaning that all the schemes that you see here, we are conscious, of course we are modifying some of, slightly, some of the 3GPP specs in some cases.
The keynote session
but
will resume
we are complying.
Please begin to make your way back up to the conference room. Thank you.
Okay. So we are complying as much as possible, except when we introduce a new functionality with the 3GPP specs. So we are somehow industry compliant, though we come from the research part. So technology transfer is key. I mean, and all these schemes are filtered by companies like Qualcomm, NEC, MIMO, Sajan Compusli, the consortium. So they all tell us, I mean, researchers, yes, but this is not compliant with 3GPP specs, so we then modify our schemes. So what did BeFEMTO do then? So as I said, it's not just about the small cell deployed in an isolated way. It's about a whole architecture, and this is what we did in BeFEMTO. And it's not just about the mobile network layer part, but is that standardized by 3GPP. The EPS, the default packet system. It's also, when you move to packet switching systems and packet switching transport, it's also about how efficient you make the transport and how you make both things interact appropriately. So this is also dealt with in BeFEMTO. So as you see, the BeFEMTO EPS architecture somehow expands because we're introducing new functionalities, somehow expands what 3GPP has been standardizing, and we also expand the functionalities at the transport network layer, because in a packet switch world, that's quite relevant. And the figure also shows two key nodes in our architectures. That is the home node B, I mean, that is substantially modified, particularly for some of the scenarios that we are considering, and also the local femto gateway, the LFGW, which is a new node that we introduced in some deployments of femtocells that we call networks of femtocells. What's the difference between regular deployment of the standalone femtocells and a network of femtocells? It's cooperation, basically. So we want to have, if you have millions of femtocells deployed, you need to have some scalable ways of deploying them. So then what you need to do first is to isolate somehow the behavior of the networks of femtocells from the core, so that the impact in both in terms of signaling and data is reduced. So this node there that we are defining is allowing us to do that, to confine somehow as much control traffic and as much data traffic to the local network, so that it can scale. So we can have scalable deployments. Of course, we are doing that complying, as I said, with 3GPP specs. So this means that this node is almost transparent, except for the management part, to the core and to regular home node Bs, right? So this is what we are doing. So if you want to have more information, deliverables, there are many public deliverables of BeFEMTO. You can go to that website. And of course also to the CTTC website, where you will find pointers. So talking again about networks of femtocells. Of course, in BeFEMTO, we're also discussing about the standalone deployments of femtocells, about mobile femtocells, about outdoor relays. But let me just focus on this one. And this, in fact, is a diagram of the testbed that we currently have deployed in the CTTC. What you see there is somehow of a mesh of femtocells deployed in the CTTC premises, which are wirelessly connected. So we have kind of all wireless local backhaul. And this is our network of femtocells. And some of these femtocells are acting as gateways towards the core. So these gateways will confine the traffic to this network of femtocells to have scalable deployments. And then, of course, this introduces some challenges in terms of mobility on how they organize, how they handle data, what are the most appropriate points where you can offload traffic. Well, there are certain challenges that we are talking about afterwards, but what is the main application that these kind of scenarios may have? So one example could be this conference hall. So you have a fast and cheap deployment because you have wireless backhauls between femtocells in conference halls, in stadiums, in temporary deployments, but also when you start seeing discussions on outdoor deployments of small cells in lampposts, well, it's not quite likely that you will have a fiber to each of these small cells. So wireless deployments start making sense. All wireless deployments start making sense. And I just recently read some news of the YGIC Alliance setting their target as trying to build small cells to apply these 1 gigabit per second or more wireless links to deploy small cells. So we are there. I mean, the architecture of BeFEMTO is prepared for doing that. So, and of course, in the CTTC, we also have some framework that allows us to be productive in the sense that we can completely change the scenarios that we're testing in terms of the traffic that we introduce, on how we handle the experiments and all that. As I said, this is already built in CTTC, and we are testing it, in fact, now, because BeFEMTO is finishing in June, and we are presenting it to the Commission in September. So, and it will be done, part of the demos will be done here. So, one of the things, as I said, one of the challenges at the transport network layer is the backhaul, this local backhaul that I was just mentioning. So if you have a packet switch network and you have a wireless backhaul, one of the challenges is how to best use these resources at the transport network layer. So how you make sure that all the resources that you're using are really used and you don't spend money that is not really used, right? So what we did was to design schemes at the transport network layer that adapt to the traffic conditions of the wireless network, and depending on how congested it is, you can distribute more so that you evenly consume the resources of the wireless network. What you see here, what you see there is a matrix. This matrix, each circle represents a node. This is a simulated node in this case, but we are doing the same test over the testbed that I just mentioned. So each circle is a node. And the darker the color, it means that the more packets are handled by that node in the experiment. So if you have a source here and a destination there, if you have a congested network, you can dynamically adapt the distribution of the traffic. And if you have a less congested network, you just have shortest path. So this is something that we did. And the results right now, up to now, as I said, we are extensively testing it now. But they are quite good. What this figure is presenting is the delays that we are getting. So as you put more traffic, as we go to the right in the figure, as you put more traffic, in our scheme, the improvement in delay is much better. And not just the improvement in average delay, but on the distribution of the delays. So the dispersion of delays is also much better in our scheme. despite distributing more the traffic depending on the traffic congestion. This is one of the things, this is one of the challenges that we are facing at the transport network layer. Of course, always taking into account that we have 3GPP traffic on top. And then, of course, the other big issue is we want this network of femtocells to work in a coordinated manner. So for that, SON at different levels, not just the way 3GPP is standardizing it now. As I said, you also need some kind of SON at the transport network layer, self-organizing and working, right? So there are issues at the location management level. We design schemes so that you have an efficient signaling when you try, by using tracking area lists, you dynamically adapt the size of this tracking area list to have the best trade-off between tracking area updates and paging updates, right? So this is one of the challenges we are facing. Other challenges we are facing, and we studied and proposed solutions, is IP flow management. And I include there offloading. Not just analytically, but also experimentally, we are evaluating this kind of technologies. So how to best, depending on the conditions, and not just using 3GPP standardized technologies, but also Wi-Fi, for example. When you have multiple networks, what's the best way to send the flows this way, that other way, aggregated, distributed in different ways? So this is something that we are also doing at the CTTC. And in terms of SON, of course, let's say the more traditional way of understanding SON in the way 3GPP understand it, radio resource management. So we've been designing, conceiving, and truly evaluating machine learning techniques for power allocation. Other partners have been testing in any scenario you can imagine between macro, femto, interference between macro, femtos themselves in the network of femtocells. I mean, the important thing is that there's cooperation. It's not just a deployment of small cells in an isolated way. I mean, they should work in a cooperative way, right? And we are also doing it experimentally. So our colleagues at the engineering unit are testing scenarios in which the macro UE measures the interference received by femtos, sends it to the macro, which in turn sends it to the femto, and then the femto adapts the behavior not to distort the transmission of the macro. And this is done experimentally in the CTTC also, by adapting the bands not to distort the transmission of the macro, right? And we are also testing other issues, as I said, like mobile femtocells, like access control schemes to local services when you come to a certain organization, but this is just some of the issues that we are dealing with in BeFEMTO and in the CTTC as contribution to BeFEMTO.
Visit cttc.es for more information.